The very first thing I wanted to say that it is a privilege to have this platform called AICT ATAL platform, and because last month we have orientation kind of programs there. We have discussed various advantages or facets of this platform. So it is a kind of unique opportunity for the participants as well as the organizer, both ways, because we are naturally in this situation due to this epidemic situation. We have hardly have this kind of platform where we are engaging a different set of participants for different set of development FDB programs, right? So in the month of November, we have also conducted 2 of the FDPs in our institute, NIT Kurukshetra. And as a part of resource person also, we have connected to the different FDPs under this AICT. So I would like to congratulate to the team who are organizing this FDP on human-centered computing, because HCC is one of the upcoming application area. There we are basically connecting different expertise, different systems into some sort of platform where we can achieve HCC-based services, right? And it is a privilege to have participants in these FDPs where we are discussing these kind of concepts, right? So thank you, organizers, for considering considering my presence in the FDP as one of the experts. So thank you for that. And I think I can congratulate to the participants also. They have connected for this FDP. They will be getting a lot of information, a lot of developments on the different application domains, actually, because HCC is basically you can say the application domain wherever we found that a user is connected, a user is using some technology. So let me briefly share my presentation. And whenever a participant is having some sort of doubt or some sort of query, he may simply enable his video. I would like to request the participant to simply enable the audio and raise the question. That will be the most convenient, because during the presentation it will be difficult to switch from PPT to this chat box, right? So yeah, few questions we can take at the end of the presentation, but primarily let's have this kind of voice-enabled communication or exchange of ideas, exchange of questions, right? So let me share my screen. I hope it is visible to you now, right? So I hope it is visible. So you can confirm, yes or no, please.
Yes,
Dr. JP? Yeah.
Yes, visible.
Yeah, thank you. So let me put it on the full screen first. And if the slides are not moving, let me also at that point of time that maybe sometimes it is observed that slides are not moving, though I'm moving the slides or sliding the contents. Right. So the topic for my presentation, that's what we have planned, is modeling human interactions. Right. And on information visual. So two important key terms are here placed rightly on the title of the discussion. The very first talk is related to the HCC only, which is called human interactions, right? Because nowadays we are getting a lot of systems which are primarily designed for user purpose, primarily designed for user interactions, right? We are getting a lot of information search system, data systems, or any kind of systems. And on these systems, we are having some sort of, you can say, the interface where user is interacting, right? So when we say we are trying to design a HCC-enabled system, right, or maybe HCC-driven system, the interactions of users, interaction of humans are very critical. They will be basically helping you to achieve or helping you to improve the system performance or to improve the system basic functionality, right? So naturally, whenever we are having something to show the user on the GUI or the interface, naturally these retrieved or extracted details will be portrayed on some sort of visuals, some sort of information visuals. And we are trying to say that, if we want to have any information system, you should always have a interface there you are placing the informations, and you can offer these visuals to the user so that he can operate on these information visuals, information objects, information elements, right? So the theme of this particular discussion is to highlight the fact that we can also design a human-centered computing driven system by utilizing these human interactions on the information visuals, right? And we can model these interactions on visuals. We can always plan a system, design a strategy to model all interactions, all user interactions, to achieve a better system, to achieve an improved system, right? So one of the possible case study, one of the possible research area which I'm working upon is the interactive information search, or maybe you can say interactive information retrieval. So we have this existing presence of various information retrieval system in the form of search engines or search systems, and nowadays we are having these conversational IRs like Alexa, Siri, and all these things, where user is simply applying his query onto the search systems, right? So that's why this thing has been added, interactivity, right? You can see interactive. So interactive means now we have something addition on the system, addition on the top of the system to operate, to play, or to contact to the system, right? So let's briefly move to the outline of the presentation. So I will be covering this fundamental aspect of the presentation. There we will try to understand that why this intelligence is important, why this user's intelligence is a very critical aspect of system modeling, right? So whenever we are saying a user is intelligent, or it is user's intelligence which is the important aspects, we will be discussing upon the basic notions of the intelligence aspect, and how user interactions or human interactions are basically serving some purpose to gain these intelligence, right? Because intelligence is closely related or closely reflected into the user's interactions on the system. After that, we will be moving to the next aspect of the presentation, next phase of presentation, where we will be opening about possible dimensions, possible facets of interface, or maybe visualization of information, so that we can effectively provide some sort of information to the user, and specifically we can capture users interaction on the information effectively for the system design. After that, we will be opening about or discussing about the different aspects of the different existing systems where we are providing these information visualization, and we are gathering user interactions. So in this, we will be talking about different existing systems like uRank, pulp system, beehive system, intent stream system. So there are various systems which are available, which are existing naturally for a very specific type of data, very specific type of users. So these systems are available, maybe they are available in the specific domain, maybe they are existing to the certain laboratories domain or some kind of things. They are not, these systems are not available for generic users, not for generic search systems. They are available for only personalized or specific type of users, right? So we will be taking upon these systems as a case study to understand that how this is how we can plan the modeling of human interactions on the visuals to achieve a human-centric system, something like that. And the last part of this discussion, we will be trying to understand that how this modeling of human interaction or user interaction on the information object visuals can be modeled, can be utilized to improve a search system, right? And in this, we will be talking about two systems. One is intent view, and second is AIDE system. So these two systems we have designed with our students, and we have got a few good publications on the top of these systems, right? So with this, let's move to the presentation. So the very first thing, let's thoroughly understand that why this human intelligence is important, and what is the typical definition of intelligence, right? Because intelligence is indicating, or it is highlighting two or three aspects of the human interaction also. It is directing, or it is navigating or emphasizing basically the importance of interactions interactions which we are reflecting, which our user is reflecting onto a system, right? And these human interactions, user interactions, are partially the reflection of user intelligence state. So primarily, there are two broad definitions available for intelligence term. Intelligence as an proper English term, which says, first definition says, it is the ability to learn or understand or to deal with new or trying situations, right? So you can read here, it is the ability to learn. That is the primary state. That is the primary, requirement for the intelligence system, for the intelligent human being, right? It should have some sort of ability to learn or to understand or to deal. Dealing means you are applying your gain understanding, gain ability to solve or to handle some situations or new situations or maybe repeating situations, basically. So you can broadly understand this definition, and you can correlate that. Okay, all these basic machine learning techniques, machine learning approaches, algorithms are based on this primarily basic definition of intelligence, right? Similarly, if you take a different definition of intelligence, it is the ability to apply knowledge. Now, here we are saying it is the ability of applying knowledge, right? So here you are having, naturally, ability of learning is increasing. It is implicit to that, but the primary ability, the primary responsibility of our intelligence system, according to the second definition, is to apply the knowledge. Whatever learning you have gained, you need to apply it. And it is to manipulate the environments or the situations and to achieve some objective, right? So if you can see carefully, these advanced AI-enabled systems, these recently developed deep learning-based systems, are primarily falling into these definitions. They are trying to apply the gained knowledge to manipulate or to handle some situations with respect to some criteria, right? So, so these two definitions are basically indicating and highlighting to have at least two states, two level of intelligence, right? So whenever we see the different human beings also, as far as system design concerned, we can place these two broad types of humans, these two broad types of users. So in the upcoming slides, we will be talking about the different types of user also. So from this point, after getting the definition of intelligence and after getting the the primary or the base elements of intelligence, let's understand, okay, why do we need to have intelligence state, right? So why it is very important to have intelligence state to a human being or to a system, to a software system, right? So from here you can see, in the definition you can see we have placed that the humans are basically, or maybe any user of the system, software system, is by default nature, or maybe by the native nature, he or she is a seeker, right? He is trying to seek some sort of information, some sort of data, some sort of knowledge, right? Maybe from system, or maybe from human to human conversation, right? If you observe the conversation between two human beings, you can easily find that, okay, whenever we converse with someone, we try to take out some details from the conversation, right? So conversational intelligence is one of the aspects of SCC. So similarly, so whenever we are engaging with system, or maybe from a human being, the intent is to seek some sort of data, information, or knowledge, anything. But what is the primary reason? It is basically primarily driven by the tendency to enhance knowledge, tendency to enhance the knowledge, tendency to basically gain some social awareness, intention, or the objective to gain or develop some complex intellectual skill. It could be the objective to learn a programming language. It could be the the objective to learn about the different development, different advancement in a certain area, something like that. So it is always with respect to some of these reasons. Yeah, we can have more reasons for that, but primarily these are the reasons, right? And after getting this some set of intelligence, if you see carefully into the behavior of intelligence gaining, intelligence achieving, primarily because we don't have much idea about the possible objective, possible aim, or possible purpose for which we are trying to gain intelligence. Initially, whenever we go for the objective, go for the purpose, go for the aim to gain some intelligence, to some awareness about a topic, about a scenario, this is how we are conducting ourselves. We basically conduct ourselves by having some imprecise questions, imprecise query with the system or with the human being, right? Imprecise means we don't have very specific idea about the initial questions, initial queries, initial interactions, right? Whenever we are trying to gain some awareness, some knowledge about a topic, and basically a topic, we used to engage with the system and human being by these uncertain or imprecise queries or intents, right? So in this situation, whenever you don't have, as a user, you don't have much idea about the possible query, possible questions, your conversation may be extend to the 1 or 2 or 3 or something like that. And if you basically converse with the system, engage with the system, interact with the system, your interactions will be extending to the multiple, multiple queries, something like that, right? So it is very basically naive approach to have these kind of situations, and we are often facing these situations because we do not have any idea about our estimate of our intelligence or knowledge which we have right now. So if someone is, or some system is indicating or placing an indicator that you have gained this level of intelligence with you after interacting with the system, or maybe after interacting with the individuals, you could have some realization that, okay, after engaging with systems, after engaging with individuals, I have got this level of knowledge, right? So these are the some reasons, these are the some root causes, you can see. This is how, or this is basically we are getting different set of knowledge. And if you observe or correlate that with advancements of different details levels, because data is something which we often gather, which we often collect from the interactions with the system, right? Then we could have collected some sort of information or knowledge or wisdom. So whenever we are interacting with a system, or maybe from an individual human being, our intention is to gather one of it, right? In some instances, we are gathering data or facts or unprocessed or raw details. And in some situations, we are capturing or taking out or extracting some information. In some situations, we are actually very inclined to get some set of knowledge, right? And typically in the life, if you see, there are some situations where we are intended to get some sort of wisdom from some specific or very trained or experienced or knowledgeable or maybe informed persons. So in the whole circumstances, various circumstances, situations, we are getting different details in the form of data, information, knowledge, and wisdom. So if you correlate this hierarchy of these details, if you take two scenarios, one scenario is a human being is available in front of you. Second scenario, if this system is available to you. Now, if you carefully correlate that whenever we are conversing with a human being, what are the situations where we are taking out data from the conversation from a human being? What are the situations we are taking out the data from a interaction with systems? You can easily correlate that there are various situations where we are collecting different details from the system, different details from the human being, and to achieve this extraction, to achieve this conversation, we are having different set of strategy, different set of intelligence, right? And that's why nowadays we are getting a lot of terms called machine intelligence, computational intelligence, then swarm intelligence also now coming. So this intelligence is basically intelligence built with some strategy onto a systems, are having this analogy, right? So you can have human and systems. So there is a strong analogy between interaction of a user with human and interaction of user with system to achieve some sort of data, information, knowledge, or wisdom. So it is simply having analogy. So now if you see, so this is one of the important aspects to understand, right? So as far as interaction with the system, because to conduct a discussion on the topic which you have taken for this FDP, this particular session, we cannot take each and every time this human presence or human to human conversation. So our focus from this point is to have a software system or maybe information system for interaction. So from now we are considering this presence of user as a human user, and in the front of this human user we are placing a software system or maybe information system. So whenever we are considering that a user, a human is interacting with the system, the most convenient, the most suitable form of a system for conversation, for interaction, is a system with some sort of information visualization. And that is what we have taken as a research issues, research challenges, or research direction from the last, at least from the last 10 to 12 years. We are placing some sort of information visualization on the GUI, on the interface to a information or maybe search system or any kind of system we are placing. So if you see, basically, if you see the role, the possible contribution a visual element or visualization could offer, it is basically helping you to achieve some sort of control, some sort of, the privilege to the user so that he can easily operate on the data or maybe information or maybe knowledge which is visualized on the interface where user is operating, where user is playing with the data, right? So it is primarily, so this role of information visualization has been realized when we have observed that now we are getting a lot of data from the different machines, different labs, computational data, it could be a transactional data, it could be a user generated data also, because this emergence of social platforms, social networks, we are getting a lot of data generated by the user contribution. So a lot of user generated data has been realized as a big data, and because of this set of data we are getting a deluge kind of situation where we have humongous data situations to deal with, and whenever we are designing a system to understand this data, to operate on this data, and naturally on the top of that a different user is placed, there you have to provide some sort of convenient display, convenient way of representation to the data, right? And there is this role of information visualization has been realized. So so it is basically this information visualization, or maybe the importance of information visualization has been realized along with the development or along with the evolution of big data situation, right? So yes.
One thing, sir. So
Yes.
sorry to interrupt. So
Yes.
are you using the slides?
Yeah, this slide, this title is augmenting information visual.
Sir, actually we are not looking, means we cannot see the transition, sir.
I think this, is it visible now?
Yes, sir, it is not full screen. Most probably
Okay, now I can now mark it. So it is visible. So sometimes it is freeze. That's the problem with me, right?
Yes, sir.
So I think it is visible perfectly now.
Yes, sir, it is visible now.
Okay, so there we have emphasized this importance of information visualization, and it is mainly because the evolution of big data. And when we realize, okay, information visualization could have a significant role on the, at least on the data analytics and maybe information processing or information representation. So we have clubbed actually the big data with advanced analytics requirements and the HCI part. So if you club all these things like big data aspect and this advanced analytics with HCI, you can always have this presence of visualization to operate, to perform, to enable some sort of features on the data, some sort of operations on the data, right? To help a user, to assist a user, right? So you can always have these visualization or visual elements on the GUI to have convenient operation, to have a convenient data play by the user on the data, right? And you can, if you see how basically this visual elements or visualization of information is helping to a user. So it is simply enhance the user's cognitive perception or user basically visual perception about the data, right? Because it is showcasing or demonstrating the use data semantics or data structures in a different layout, so it can easily open up about the various dimensions, various aspects of a data to the user. So it will enhance it will assist a user to achieve some sort of data play along with it, right? And significantly, it will reduce or minimize the efforts which user is engaging or user has to involve during this understanding of the data content and its semantics, right? So along with it, it is also significantly reducing the user's effort on the different actions on the data. So one of the action could be query formation on the data. So it will significantly reduce or minimize the user's effort on the different operations, right? So if you see the various systems nowadays available, you can easily correlate that there are various systems, there is various recommended systems has been designed and populated for the users purpose in the internet actually, right? So you can have various supply chain systems, various information systems there. They are placing some sort of GUI to operate, some sort of information visualization to operate by the user, right? So one of the example, let's take it is I hope slides are visible. Benefits of the visual portrait. The title of the slide is benefits of visual portraits. I hope it is visible.
No, sir. Actually, we are saying augmenting information visuals.
Okay, I don't know why it is not moving. Let me again see. So yeah, so this is the slide which I am sharing. So I hope this slide is visible to you now. I can do one thing. Can I play with this view only? Is it okay?
The presentation is not coming, sir.
Okay, it is stopped. Okay, let me again. Yeah, so this is the slide I'm just discussing. It is about to have some sort of idea that this is how visualization or information visual can have some sort of impact on the information understanding. So if you take this slide, if you understand the impact, this data from LinkedIn network has been extracted, and here we have extracted the possible followers and possible users. So you can see there is user called Samir Khan is placed on the center of the graph, center of the network, and on the left side of it, on the left side of Samir Khan user network node, all the users which are which Samir Khan is following are placed, and all the users which are basically indicated in the blue network or blue nodes are placed in the right side of the graph, right? So with this, you can have, naturally we have taken one view on the data, one view on the network graph of the user Samir Khan. But if you explore inside this graph, explore into this nodes or maybe node-to-node connectivity graph, you can easily realize that what is the other important, other relevant users you could have, right? So basically, a particular visualization or information visualization will offer you, the first thing is naturally is the capability to have the information portrayal, information visualization about a complex high dimension or multi-dimensional data. That is the first thing you can achieve. You can easily portray high dimensional data. So if data is having more than 3 dimensions, you can easily portray it by these information visualization elements. And when we have this visualization, naturally you can identify the other objects of interest, right? Because naturally this graph, which is visible to you, is designed with respect to Samir Khan as a center node as a user. But if you want to explore to the different user, or if you want to explore to the other semantics of this graph, or the semantics of this relationship between the different users, you can always explore to these semantics, right? So you can easily explore into the different subject of interest, subject of your hypothetical interest, right? Among this set of millions of users, right? So this sort of visualization will help you to understand this relationship between the data object, which are little difficult to understand in the traditional view of the data, traditional view of the data collected actually, and if you want to derive some new hypothesis or new insights based on this visualization, that you can achieve, right? So this visualization, it will help you to derive new hypothesis or derive new theorems or any kind of research based questions or any insights you can develop, right? So with this, let's understand, let's take another example. I hope this slide is available to you. This slide is visible, I hope. So if you see at this point, let's take another example or another system which is developed by GE, which is General Electricals. They have worked upon the collection of data, collection of person who is having some disease. So they have collected this 72 million electronic records of different persons, right, in the Europe actually, and they have worked upon a basic system for the physician. And by having this simple system, a physician can identify that if you are having sore throat actually, right? So based on the basic symptom, a physician can easily identify the next possible disease which this simple throat may lead, right? So they have collected. So to design this system, to design this correlation between different disease, naturally based on the gender specific data, so they have designed this simple GUI. They have simply portrayed that if you are having some disease, by having this only disease information, you can easily portray that because of this initial disease, you may land up to the different disease with the intensity, right? So to understand the correlation between two diseases, you can always have this interface to understand, to have the possible treatment, to have the possible proactive treatment based strategy, right? So this is the capability of information visualization. So we have, so GE has collected the data of 72. Okay, someone has by mistake muted, so now it is, I think, okay. I'm audible to you. So okay, so basically, this GUI. I don't know why is it happening by mistake, or I don't know. Okay, so I am getting repeatedly muted. So please keep me unmute, right? Otherwise, it will be little difficult. It is coming from the participant that I am being repeatedly muted. So, or we can share something. I hope I'm audible now. So yes. So okay, let me continue. So from here you can see this simple interface is basically enabling a physician to understand the correlation between different possible disease, and based on that he can proactively plan the possible treatment or possible medicines, right? Similarly, if you see another system developed by Google to portray the contribution of the different musical tracks, musical genres, right? So between the year of 1950 to 2010, they have gathered or extracted all the possible music tracks and music albums which has been released, and they have plotted, they have visualized this extracted details about the different tracks to understand the contribution or the presence of different genres music, and you can easily understood the different contributions of different tracks of users or musical singers or artists, and their contribution onto the different type or genres, on a different users, different years actually, right? So with this, you can have a inside view about the possible types of music, possible types of genres by the different sort of artists, right? So similarly, if you can see, there is this interesting data which is visualized. So in this data, you can easily see that there is a very interesting estimate has been prepared based on the contribution of different tweets by the global user on a different timelines. So this timeline is basically indicating the average happiness index on a specific year, within a specific month, and within a specific week, because of a specific day or maybe event, right? So you can carefully see the events are written, and you can spot here the Christmas Day event is contributing to the highest score of happiness, and this this colored dot on the Christmas Day indicating that on which day it is falling, right? So it was falling on the Wednesday in the year of 2012, and it is contributing. So 2012 Christmas Day is generating this around 6.224 scores or happiness average index score, right? So this is the capability. So here you can easily understand that what is the impact of an event which is observed on the Twitter platform, right? So similarly, we can draw or we can derive this kind of semantic analysis on the visualization by extracting simple form of data, right? So with this, I hope slides has been available to you. Slides has been available to you, right? So with these real-time systems or maybe real-time situations, we can say there are two broad categories, or there are two broad classes of information visualization which we have. The different set of different types of systems. One is type of text visualization, where we are simply visualizing the elements or text elements, and the second sort of second type of visualization is primarily driven by the documents as an object. So when we could have this scenario that, okay, what should I go for? Should I go for the text visualization based approach or strategy, or should I go for the document based visualization for my systems, right? Because eventually, whenever we are designing a system, information system where user will be interacting, you should be carefully deciding that what is the nature of data you have with you, right? And in some situations, we will have text as a atomic unit of data which we have, and in some situation, it is the document, it is the collection of text, right, which we have to operate on. So whenever we have text as a unit data which we have to deal with, or unit data which we have to present to the user, naturally we can achieve some sort of analytical search, or we can have some sort of similarity based search on that data. And to visualize this text sort of data, you need to carefully work upon the text string which we have received, and you have to carefully deal with the semantics, the relationship between these text elements, right? And to deal with it, you have to properly maintain some set of meta information, right? So whenever I'm saying semantic information, it is always having this meta part also, right? And to deal with it, to prepare this data for visualization, you can adapt clustering and any topic modeling based approach, topic modeling based technique, right? In the case of text visualization, whenever we are designing a system for text visualization, the challenges are the scalability of the text, because we are getting a lot of data in the form of text nowadays. So scalability is one of the prime issues which we have to tackle as a system designer. The second is recency. You have to always present the recent versions of the text, recent version of the updated text data. And naturally, the pre-processing involved in this whole text processing is one of the key challenges, right? So along with these three, yeah, we could have other challenges also, but these three are the prime challenges when we are designing a system to visualize the text data. In the second scenario, where we have documents or the type of documents to visualize, right? So you could have naturally, so whenever we are trying to design a system to visualize the documents, you can achieve either browsing or exploratory based search, right? And to deal with or to operate achieve some sort of visualization, you always have to be careful about the documents and its relationship with other documents, right? And the content within it, right? So feature of text within it, right? So the challenge in the case of document visualization are the different features of the document, different feature of the collection of the text, and this document to document links, and the possible overlap between these two or maybe set of documents. So with this, these are the highlights, primarily the basic highlights about the possible types of visualizations. So with these two types of visualization, we can claim that with these two types of visualization, we can say that, okay, whenever we are planning a system for user interaction enabled by information visualization, we could have two broad types of system to design. One is driven by text which we have collected. One is type of documents. So for each type of visualization based system, we have to carefully select the strategy. We have to see carefully the challenges and the possible achievement which we have, which we could have with the system, right? So with this assumption that, okay, you have this idea that now you can relate that what is the different types of system I'm dealing with and where this system is falling into, whether it is a document visualization based system or it is a text visualization system. So if I explored, so actually as a part of study, we have gone through the various, the system where we have some sort of visualization. So we have actually explored to the research literature in the last, I think 4 or 5 years, and we have observed there are various systems has been designed. There are various, interfaces has been designed to assist user, right? To assist user on his data play actually, right? So whenever we as a system designer, we as a researcher of the information science or researcher of the SCC actually, whenever we are considering any sort of hypothesis to design, hypothesis to be solved, whenever we are exploring the literature, you could find various systems and you can easily understand that, okay, this particular system is emphasizing on this aspect to achieve some sort of HCC, right? So similarly, we have also explored the literature and we have come up with a lot of systems and a lot of, the research area or maybe the area of thrust. So we have realized there are 3 broad areas where system has been designed, where emphasis of the system's design has been given. So there are 3 broad areas. Naturally, there are some systems which are focusing upon the interaction level. So they have done something, they have contributed something on the user interaction level onto the system, on the software system. There are some systems, some approaches, some techniques has been designed to achieve something on the middle layer to assist to the user interaction, to achieve some sort of interaction. Similarly, there are very few systems which has some algorithm placed in the database layer to achieve a level of interaction on the user presence, right? So here you can see carefully at the user interaction level, because we are talking about this sort of user or human interaction. So if you see at the user interaction level or human interaction level, there are various systems which has designed by considering only 2 possible aspects which can be designed, which can be modified, which can be available to the user. The first aspect is that there are few research works, there are few systems have been designed which say that, okay, we can have some sort of visualization layers. So there in this, basically we can have either visual optimization based interfaces, there you can simply portray the informations, and secondly we could have a visual interface tool on the GUI, right? So when I say visual optimization, it means it is a system will be having a simple GUI, their information will be pushed, but user will not have any control on this. User will not have any operation, any feature to operate or to perform something on this visualized information. And the second place, there are various efforts has been there, various tools has been proposed by the different researchers. They are providing the information visualization And to operate on this visualization, they are providing some sort of features, some sort of control, some sort of options, right? So in the data visualization layer or maybe aspect, we could have two possibilities. And along with it, in the user interaction layer, there are some works, some interfaces has been designed where some level of exploration capability has been given on the GUI, some level of capability for query formulation is also built, some sort of query interfaces has been designed, right? Like in the recent advancement, we are getting a lot of conversational IR systems. So these conversational IR systems are having this novel query interface. There you are simply placing your query by voice input, and they are getting these voice inputs translated into the text inputs and extracting the details about your query, right? So naturally, as far as user interaction level concerned, you could have these two possible areas or maybe sub areas, and within each you can have possible types of system designs or maybe system functionality or maybe plugins design, right? So this is the literature presence layer. You can always go for the different techniques on the middle layer. You can see different techniques on the database layer always. But our focus for this discussion is only on the very first aspects. So let's go with this literature. So if you see carefully that whenever we are planning to design a information system, and whenever we are having this consideration that naturally for my system users will be operating upon the GUI, so one factor is very important here, that you should always have an idea about the possible type of user about your system, right? So in the literature or maybe in the common sense also, you can realize that in normal settings, actually, we could have three broad types of user to any information system. The very first type of user type is called naive user. Naive user is user who is not having any idea about the possible semantics or possible content of the data, right? Yes, he's having some objectives, some assignments to solve, and some sort of aim to solve, but he's not having a basic sense that how this search or this interaction should start, right? That is the naive user, we can say. The second type of user could be a user who is having some sort of idea about the possible semantics, possible content, possible, the hints or clues about the data, right? And based on this initial idea, initial knowledge, he can easily correlate that, okay, this data is relevant, this data is not relevant, this part of information visualization or information element is important for me, I can operate on it, something like that. Similarly, if we go for the third and the best type of user, or maybe most informed type of user, who can be called or referred as the expert user. So the expert user is the most informed or the most well-knowledge or well-updated user of a system, right? So whenever we are trying to design a system, you should always have this understanding that, okay, which interface type will be suitable for my type of user, so user of my system, right? So if a user for your system, information system, is a naive user and he will be operating onto your system, you should always have an interface where informations are simply visualized. You do not need to provide any action, any operation control, any features to operate on the visualizations, right? Right, because user is having some sort of navigational search in the case of naive user type. Similarly, if you have the trainee or maybe programmer user, you can see a trainee user is having some set of ideas, some set of basic understanding about the data, possible data. So here you can provide some visualization, some interface. There you can provide the clue about the data, clue about the data sample. So in this case, or maybe for this type of user, you can directly provide the data samples. And based on these data samples, because user is having some idea about the data content and the data semantics, he can always perform some labeling, some review, some sort of direct data play. So for this type of user, you can always provide the direct data value. You do not need to provide the representative version of the data, right? For the expert type of user, because the expert type of user is always informed about the data content, He's informed thoroughly about the data content. He's always informed of the possible semantics between the data objects. And he's always interacting with the system to validate some sort of thesis or hypothesis, right? So you should always provide some sort of, some sort of novel core interface, or maybe some sort of directly semantic based or meta information based systems, so that he can directly validate a thesis, right? So it is very so all these elements which are placed below these interfaces could be naturally of similar nature, or could be of different nature also. But the purpose of this discussion at this point of discussion is to understand that for different type of system user, you should always paste or make available different type of interface, right? So now from here we are going to the second part of this discussion, where we are emphasizing that to design a system with information visuals or information visualization interface, there are two broad dimensions. There are two broad, the parts where we should always have some sort of attentiveness, some sort of idea that how to plan this dimension for or while designing my interface. So there are two broad dimensions whenever we are designing our information visualization system for user interaction. The first dimension says what are the visual implications we will be having. The second dimension is visual accomplishment, which says what are the possible achievements, what are the possible accomplishments we will be having on this GUI. So you should balance. So while designing the information visualization interface or the interface for the user interaction, you should always balance these two dimensions and carefully place the visual elements on the GUI to achieve these two dimensions and their internal basically characteristics, right? So let's open up about these dimensions. So if you take the first dimension, which is called visual implications. So if you carefully see any visual interface systems where we have visualized informations, you can carefully observe these 5 different sub area or maybe aspects. So whenever we are designing a system as a system designer, whenever we are designing a system with GUI, with interface, with information visualization enabled applications, you should always concern about the organization of information, right? So this very first characteristics of this dimension called visual implication emphasize that you should always concern or always have a careful attention about the visual organization of the data. Whatever data you have placed in your database servers, whenever you design to plot on the GUI, you should always think about how it will be grouped, how it will be shown to the user in one single entity, right? Second dimension is that in the visual organization, second dimension is visual attention. So in this you can see how to grab the user's attentions. Naturally in the GUI there are various elements has been placed, and if you want to grab the user's attention at any point of time, you should use some strategy. You should use some color scheme, you should use some texting scheme, something like that, right? And after that, after having some element to grab the user attention, you should always have indication that after looking at this visual part, you should go to this part. So your GUI system or GUI interface should have this sort of indication that user should first of all focus on this aspect, then go to this part, then go to third part, something like that. So you should organize the data collected or data representation in some sort of organized way, so that user can always navigate his search, navigate his interest, navigate his intention of information seeking in some directional way, right? This is the first aspect of visual implication. Second dimension of second property of visual implication is that basically which structure you are using to organize this whole information, those visuals. So naturally you can have any organization structure. You can visualize the information in tile bar or maybe horizontal bar or maybe any other organization. So it is very important because the structure for visual representation is having some critical role, right? So in the upcoming slides we will be taking about some examples also to understand that how structure is playing a role. in this visual implication, there is third dimension, the third property, which is says modifications. Modifications says naturally for the initial query you will get some sort of organized information, right? And after looking at this information, what is the feature you are giving to the user to modify the current visualization? So you could place a search box again. You could place some sort of drag and drop option to the user. So it is very important to have this visual transformation option, visual transformation feature on the GUI, right? So after this, let's go to the second dimension. Let's understand the second dimension, which is emphasizing the another aspect of any information visualization tool, which indicates the possible achievements we could have on a GUI, on a information visualization GUI, right? So visual accomplishment indicates that by visualizing the information in a structure, in an organized way, you could achieve either simple understanding about the information, simple understanding of data, or you can have some summarized representation of data, summarized representation of understanding of the data, and you could have some high-end application, high-end operation like searches. You can perform a targeted search or maybe focused search by having this simple visualization of data, or you could have some sort of help by the visualization on the prediction and the recommendation, right? So by having simple visualization of information, you could achieve simple understanding, summarized understanding, or you can achieve a simple search, or you can achieve a prediction or recommendation on the data, right? So you can achieve any sort of user related operation on the visualization, and it is broadly controlled by the second dimension, which is called visual accomplishment. So with this, now let's understand, let's take some use cases. So the first use case is coming from the literatures, and this is one of the systems which has been designed in the year of 2016 by a lab, right? And it is basically developed on the top of scientific records. So there you can see carefully. Now let's relate each and every dimension, each and every property of visualization, right? So we have two dimensions, visual accomplishment and visual implication, and within each we have placed different properties. So let's open about. So this is the basic system, basic text visualization system, which is built on the top of scientific set of records, right? So all the records, all the scientific records or their information has been extracted from the ACM digital library, basically, right? So here for starting the search, a query box is given, right? And here you can simply submit a query. Simply submit a keyword as a query, and in the A block you can see, in the A block you can see there are various keywords has been placed, right? So these keywords could be the previous, it could be the previous set of keywords which has been placed in the system, right? So in the set, in the portion A, on the part A, these different keywords has been placed, or history keywords has been placed. So if you type collaborative performance or collaborative item performance or item collaborative performance, you could have these set of results which are visualized in the section C or part C. And here you can see, peripherally see in the part D, the presence of each query keyword has been visualized to drag some sort of, to grab the user's attention, actually, that you can easily estimate that in the very first result or in the very first document, performance keyword is having lot of presence, right? It is to drag the user's basically attention. It is to indicate the user's attention that this keyword is having presence and important in this result, right? So you can similarly plan a system with these enabled visualizations. Though we are having only part D as a visualization component, others are simply having, tile-based arrangements for the text data, right? So to modify, in this case, in the case of urank, to modify the current visualization, you can always drag a keyword from the part A into the search box and always modify the search. And if you are interested in some result, you can always place this bookmark option in the section or part E. There you can always maintain the list of relevant or maybe interesting set of records, right? So this is one of the interesting system where the role of visualization has been explored. Similarly, if you see another system designed by again one of the lab on the top of this IMDb database. So this database is having the details about the different movies and their meta informations, right? So this system is basically designed on the top of a high relevance structure. There we have placed the different information on a structure for the different views on the different semantics about this database. So here there is a field given, there is a specific portion given to into the user query, and based on the user interest, he can apply a basic query to the high relevance system. Based on this query, a system will generate this view. I hope it is visible to you. So you can easily see here the green boxes, green hexagons are indicating the movie objects. There we have few set of informations given like years and ratings informations. And if you see for the same query term like James Bond, you can see some boxes are indicated in the yellow hexagons. They are simply indicating that different individuals, different persons, different entities, right? So this kind of visualization is also achieved. So here hexagons are basically used as a visualization, visual structures to indicate the different type of entity, type of objects, and within each hexagons we are placing different entities, and different coloring scheme has been used to indicate the different types of entities, right? So naturally these hexagons are like, if you see two hexagons, two adjacent hexagons are placed by using some sort of relevance estimation, some sort of similarity between them, right? So it is to achieve some sort of acquisition, knowledge acquisitions, knowledge mind, right? So with this, let's do the third system. It is called taste weights. So this taste weight system is basically designed on the top of some kind of music database. So there you can always have this type of data play. So based on the collected data, based on the different genres, based on the different context, based on the different platform where it is collected, you can always organize the recommendations. You can always derive the recommendations based on the data play on the visualized data, right? So here you can, on the real-time basis, you can plug a matrix, plug the property on which we can perform some sort of visual operation to perform a visualization or to perform the data play. Similarly, let me skip this. Let me share one of the important or interesting system. So this is one of the, I think, one of the prominent system which has been largely used to analyze the contribution of, to analyze the citation analysis, to perform some sort of citation analysis on information visualization platform. So this system is widely designed by the researchers from the ACM platform. So they have created this visualization. So here you can see, you can take out any research article, and whatever research article you are searching, like in this case, this article titled as Fluid Interaction Techniques for Control and Annotation of Digital Video has been searched by the user. So this article is placed in the center here, right? So the selected paper you can see. So the selected paper is placed on the node here, and all the articles which has been referenced inside this article are basically designed or related by the left side connections, left side graphs, and all the connections, all the research articles where this particular research article has been cited are placed in the right side of graph. And in each bar, if you take the last rightmost bar or rightmost tower in the year of 2010, all the research articles published in this year has been listed here, and you can see the presence of this selected paper into this into the articles which has been published in year 2010 has been carefully visualized, right? So these all informations you can see from the top. There are these options given: find the paper, and you can have list of papers, then you can have most direct connections. So this entire view has been given or provided on the simple GUI. So by getting this inside view on a simple citation based analysis could be achieved in a very generous, or could be achieved a different advanced view on the data. Right, so this is one of the simplistic system has been designed, but it is widely used by the different individuals, different researchers, to have a inside view about the contribution of a research articles. Right. So similarly, now we can see naturally, whenever we have this kind of visualization, we can achieve any kind of analytics on the data and their semantics and their presence on the collected data set. Right. So these different use cases are widely basically affirming or maybe asserting the importance of information visualization and user interactions, right? So you can always apply your behavior, your interest on the data, and these systems are utilizing the user's interactions. These interactions may be single drag and drop. These interactions may be simply applying some keyword on the search query box, right? So each and every interaction is modeled in some way to achieve the relevant, to achieve the basically additional set of records, right? So from here we are going to a very specific domain or very specific area where information visualization and user interaction modeling is having some sort of role, and this area actually we are working upon with some of the research scholars, right? So this area we are considering is the one of the prominent research area where we are considering the presence of human-centric computation or human-centric information search, and we are referring them as a interactive information search or interactive information retrieval, right? So broadly, to start the specific detailed discussion, let's have a review kind of discussion. So in this domain of information search, we have observed two types of search behaviors. The first type of search behavior we are emphasizing called lookup based search. So lookup based search behaviors are the search behaviors we are assuming that user is aware about his search interest and he is partially aware about the possible set of results. So for a user, these results are expected. Like if I am looking for the phone numbers or maybe the names of hotel at Ahmedabad or maybe Allahabad or maybe Raipur. So you can have some idea, and whenever you are applying your search on the search systems, you will be placing a very certain kind of keywords to the search system, and you will be expecting a very expected set of list of hotels into the city, something like that, right? So sometimes it is called a fact-based search also. And contrast to this behavior, there is this behavior called exploratory kind of situation, where we are not, as a user, we are not informed about the possible set of initial queries and possible set of results which we will be receiving, right? So both ends are uncertain. Both ends of search behavior in this second type are uncertain, basically they are open, they are not clear, they are not. So both ends are fuzzy basically. So when we have observed these two broad classification, two broad types of behaviors of search, we have realized that by considering the user's presence inside the search process, by considering the user's behavior, user's interactions on this second type of search could be offering a lot of benefits to the search process, to the search systems, right? And that is how we have realized that, okay, there is a major so whenever we are planning to design a system or design a search strategy by considering user presence, you need to shift your search process. You need to shift your focus on the different aspects now, because to perform the traditional search, you could have arrangement like you will be expecting a query, and for this expected query, you could be expecting some sort of results. But whenever we are saying that, okay, now we will be placing user into the search process, inside the search process, we need to have this presence of review, after applying query, naturally you will have some results. So after getting the results, you will be having some component to observe the users presence, users behaviors, and after getting these reviews, you can possibly generate the new set of results, right? And these results will be more relevant, more specific, more user centric, because we have considered the user's presence inside the search process, and that's what we are referring as a human in loop centric search, or maybe human centric search. So naturally, in the traditional search process, you can always have these features to realize the user presence, and you can always plan the different features to take the user's presence, to take the user's interaction on the data, right? So with this, let's briefly see that what are the different behaviors, search behaviors available, search behaviors which has been observed. So traditionally, naturally, these are not all behaviors which I have listed, but if you place the different search behaviors into the different broad blocks or categories, because to basically understand the search process, we have two possible facets. Like one facet is, okay, to start the search, how much user is confident, how much user is informed, and naturally his ability to understand the result is the second possible dimension, right? So with these two dimensions, with these two characteristics, we have placed the different search behaviors, and here you can see the lookup search is placed on the first quadrant, which we are saying that both ints are known. User is having some idea about the possible query, and he's having some idea about the possible results. So this is the first quadrant where both ints are known. So you can place that fact verification, that information search, fact finding behavior, simple search onto this quadrant, because both ints are known. Similarly, if you assume that, okay, initial query is known to me, but I'm not certain about the possible results. So you can go to the next quadrant, which is having behaviors like investigation, evaluation, refining, and hypothetical analysis, all this kind of. So their questions are sometimes are certain or known, familiar, but results are not known. So all those kind of behaviors could be placed here. And if you go to the fourth quadrant, which is the most complex quadrant, you can say unknowns, unknown. So both ints are unknown, both ints are uncertain. So you can see the behaviors like explanatory search, exploratory search, discovery, browsing, navigation search. So you could place other behaviors, such behaviors here also. But the characteristics or the feature of this behavior is that here user is not having any idea, any certainty on these both hints actually, right? And you should have, as a system designer, you should have this impression that, okay, my system will be providing some sort of assistance to the user to achieve this search, and some sort of capability to build inside the system to capture the user's presence. That should be the philosophy whenever we are designing the search system for these behaviors, right? So with this, whenever we are planning to design the system for this fourth quadrant based behaviors, you should be always having these two frameworks. So these frameworks are already available. So these are often referred as a metamorphic representation of the existing or maybe human behaviors. So broadly, there are two broad behaviors has been observed. The first behavior is called berry picking behavior, which is one of the known behavior for designing the information retrieval system. So in case of berry picking, our focus is to identify the bush where the berries are available, and if within that bush the quality of berries are good, you can pick it up simply. So this simple model of selection of berries has been designed, or maybe it is helping to designers to design our information system, which is emphasizing on the focused search behavior, exploitation based behavior, right? The second alternative framework which we are getting from the different foraging behaviors. Foraging behaviors are basically emphasizing on the source search. We are searching for the sources. When naturally going inside the source is the second possible level, but the emphasis on the force search of the source. The behavior is emphasizing on the exploration of the search, browsing on the search, right? So exploration of the source is the core aim, core objective of the second behavior. So there are a lot of search systems has been designed by emphasizing on this second behavior, which is exploration. But whenever we are designing a search system, you should always balance between these two broad behaviors, exploitation and exploration. It is all about balancing these two behaviors, right? So if you see the inside view of the search process, any search process, this is the conceptual representation of a typical user search process, right? So here you can see this internal structure is show or indicating the user cognitive space, and this W is representing or indicating a real world task given to you. Like if a teacher is giving you a task, it is W. If you have got some assignment to solve, it is a W, right? And if you are having some interest to search on the internet, it is a W, right? So W could be any real world task, and after getting this task W, you could have always a cognitive perception about this work, and this CW is always a first impression about the work you have received from your instructor, and you can always map this CW into search needs form, and these search needs are transformed into the form of query keywords in the form of Q. And if you apply this Q into the search system will give you some sort of results. And so basically to get these basic set of results, any search system is using an algorithmic form of relevance estimation model, right? So we are hearing a lot about cosine similarity and a lot of similarity mechanisms. So these basic set of results for the query Q are extracted based on these algorithmic relevance, which we are referring as ER, right? So this is a very traditional setup of information retrieval or information search. But when it comes to achieve a system, design a system for exploratory search behaviors, we are going, beyond to a traditional setup. So we should be thinking about the other different or maybe relevance, because relevance is the possible area through which we can have some sort of idea about the possible presence of the user, or maybe you can say these are the area where or through which you can plan or design the system presence in the systems. So there are these possible relevance aspect which we have said as a pertinent relevance and situational relevance. And to model this, you could always have different strategy, different approach, different algorithms, different formulations, right? So you could design a strategy for modeling these two relevance, and that's what the contribution of our work. So broadly, when we observe that to model the user's presence inside the search process, we should have different relevance estimation model, different relevance measures. So we have open up this search process into three different contexts, right? So we have observed a simple search process into three different contexts. The first search context says whenever user is starting a search, he is basically looking at the knowledge state he's having and using the recall, using the remembering as a cognitive aspect, cognitive activity to start the search. So at that point of time, basically user is applying remembering as a cognitive process and he is into the pre-search context phase. He is not inside the search process at that point of time, because he has not applied anything onto the search system. So after submitting the search query, user is very much inside the search process. When a user has submitted a search query, search system has retrieved some results based on that query, based on some similarity measure or some algorithmic relevance estimation. And after getting the search results, because user is now inside the search, each and every behavior of user is observed carefully, estimated. And during the during this review part, during this in search context, user is basically looking at some results, bookmarking some results, opening some results, performing some operation on some sort of interface. So all these user interaction could be modeled, could be utilized to gather the in search context, right? So during this the second phase of the search process, search steps or search activity, you can model some sort of user interactions. So any sort of options can be provided to the user, and these options could be modeled to achieve some sort of context. Now both contexts, this pre-search context result and this in-search context interactions, could be clubbed, could be modeled to achieve the next possible proactive set of results, right? And that's what we are referring as a pro-search context. Because whenever you see the user's presence during in-search context, after getting the basic set of results, user is reading all the results, and after reviewing the results, he could have some sort of visualization on the possible set of results, because he has gained the knowledge, he has acquired the knowledge about the current task he's having. So based after getting the experience on the results, he could easily visualize, he could easily imagine about the possible set of results. And that's what we are planning. We have designed a strategy where we are utilizing the pseudo relevance on the result and the user interaction during the in search context to derive the possible set of results for the pro search context, right? And we have conceptualized a model where we have gradually worked upon a model which can balance the exploration and exploitation behaviors during the search, and we have captured the user's role inside the system, and basic on this philosophy that you should always indicate that how much knowledge a user has been gained. You should always have this measure. So you can see in the right side, left side representation, this could be the representation of search or keywords which has been retrieved after the first interaction, after the first query. So inner portion, which is indicating the portions or the area where exactly matching keywords has been placed, and all the outer area is basically area which is having other relevant topics, other relevant keywords. So this outer side, outer space, outer area is indicating the area where we are placing the results of relevance, but they are not of exact match, but they might be having some sort of similarity with the initial interest. So if you see in the right side diagram, this inner side portion has been expanded because we have considered the user presence in the search process, and during this user's presence, he has this realization that after getting a lot of interaction with the system, now system is retrieving a lot of user-centric results. So when we realize that among top 100, most of the searches, most of the results are of users' interest, users' match. It means user have gained some knowledge. He is submitting some queries of system compatibility or system similarity. We are getting a lot of results of system match or user query match. It means the the user's knowledge state has been improved. He has gained a lot of knowledge, right? So this expansion of inner portion indicates the knowledge gain of the user. So it is one of the critical aspect of the search system design also. Now let's have a brief idea about the system which we have designed. So during one of the hypotheses of the same conceptual framework, we have designed a system where we have placed a user on the center. So this view has been designed by customized library of Pythons, right? In this, we have taken the scientific documents, scholarly documents from the ACM digital library and basically IEEE is digital libraries. So we have taken out the scientific records, around 50 lakh records we have taken out, and for that we have provided a simple search box. Here user is applying simple query called computer vision. So for this simple query, the documents or maybe top 10 documents has visualized in the listed view on the right side. And if you see in this visualization where we have placed the keywords, these keywords are extracted from the these retrieved documents only. But here we have placed some sort of data play capability on the GUI. So user is placed on the center part, and keywords are represented in some sort of radar view. So all the matching keywords to the user query are placed in these different layers in the inner area. All the keywords or keywords from the documents which are having less relevance, they're not exactly matching documents, are placed in the outer area. So they are naturally of interest, of some relevance, but they are placed in the outer area. So we have placed basically type of keywords, two types of documents in this GUI. So this inner portion in basically to help you to understand, these are the keywords of exploitation interest. You can always exploit because they are having some close matching with your query. And outer keywords are of exploration intent, exploration search, because they are not having exact matching, they're not derived from the exact matching documents, but they are of some relevance, right? And the position of keyword in this view is deriving based on two things. One is there is a relevance estimate has been computed, and there is this similarity estimate has been computed, right? And this is because we have computed these two estimates to model these two contexts, in search context and in search context, in search and pre-search context. To model these two contexts in this system which we have designed, we have taken two estimates, relevance and similarity. Similarity estimate is indicating the correlation in the pre-search, and relevance estimate is designed to estimate the in-search context modeling, right? So whenever user is having this view, he can directly operate on the view by simply dragging a keyword from the outer portion. So he can drag any keyword and drag that keyword to inside or outside. So if we observe that a certain keyword has been dragged from any portion of the visualization interface to the any portion, the relevance estimate and the similarity intent estimate has been revised. To that keyword, both estimate has been revised. Based on that, the entire arrangements of the keywords on the visualization has been changed, and the list view of the records also has been changed because the query has been revised by simply having this drag and drop. So if any keyword is dragged from the outer ring or outer space to inner space, it is considered as a simple positive feedback. And if certain keyword is placed or dragged from inside to outside, it is considered as a negative feedback. So to provide this simple user interaction, we have provided two options, positive and negative feedback. And because this visualization is offering a lot of hints about the importance of a particular keyword and importance of certain topic to certain documents on the visualization. So user is having this privilege to operate on these keywords based on his revised estimation, right? So this is one of the system which we have designed. Similar to the same philosophy, we have designed another system which is called AIDE, and this system is closely related to the URANK system. There it is based on the keyword based system, and it is representing again the different results in the different section for different purpose, and on different parts user is having different capabilities to operate on. Like for feedback, he could have like thumbs are shown in the GUI, and if you click on the bottom down thumb, it is considered as a negative feedback, and this negative feedback and article will be considered to place the keywords related to the document in a different hierarchy, different relevance level, and it will be appearing in the lower ranks. It is basically penalized or some kind of degraded on the upcoming results. So these are the basic behaviors which we have planned and which we have designed. And in while designing both systems, Intent View and AIDE, we have realized the role of these human interactions, user interactions on these different informations shown, right? And naturally, whenever we place some sort of structure to represent these semantics, these information content, it will always enrich his knowledge state, always enrich his idea about the semantic relationship about the data, right? So these are the two case studies which we have. Yes, naturally we have developed 3 more systems with our scholars. There we have significantly realized that keeping user in the recommended system, keeping user in the question answer based system will also serve fruitful results, right? So due to this time limitations, we are not going to discuss that part. So let's conclude this whole discussion, right? So in this discussion, I have actually emphasized on the role of visual support for the human interactions, right? So in this we have basically placed the importance of information visualization, and you can see adaptive information visualization, because whenever we are designing information visualization, it should be adaptive, it should be a dynamic, it should be a real-time based systems where user can interact, user can play, right? And whenever we are designing a system, information visualization enabled search system or information system, you should always have some sort of idea, some sort of technical strategy to model the user's context. So like for the search system, we have designed 3 search contexts, and for each search context, we have designed a strategy to capture, to model that context into the search process. So if you're designing any search, any information system, you should always observe the user context. Context means his behavior, his knowledge state. There are various aspects of such context or context can be modeled. Along with it, you should always plan some sort of relevance model. Relevance means the user intent, user interest. You should always design a model or a strategy or technique to model the relevance aspect of the user's behavior onto the information, right? And naturally, there will be need of user interfaces, user interaction interfaces, right? So because human interaction enabled systems are the future of computing. So in the future, we will be having all systems with some sort of HI enabled interface. So whenever we are planning this design of such system as a research hypothesis, we should always take care of these different issues, right? And naturally, all of the points have been well defined. While designing a system for information processing or information management, one thing is very critical here, that whenever a user is involved, you should always balance or have some strategy to balance between exploitation and exploration, because exploitation and exploration dimension basically affects the user engagement with the system, right? So the broad philosophy and the the outlining philosophy here is to balance the exploitation and exploration, and to achieve this balance, you could place a lot of techniques. That's what we have emphasized, right? And and one of the key area which I wanted to emphasize or highlight here, that whenever we are designing a system for or maybe human interaction enabled system, you should always evaluate these systems, naturally the performance of these systems with traditional techniques, traditional matrices like you can have recall, precision, all these things. And whenever you are having this presence of user in the system, you should evaluate your system's performance by keeping these matrices like diversity, novelty of information, topicality, coverage, all these are things. And if you observe that you need to modify the definition, you need to add some element into the definition of these matrices to evaluate the system performance, you should always go for that. You should modify, you should adapt the new definition of diversity to evaluate the performance of your systems, right? So from my side, these are the details I'm interested to present. If we are having any questions, please let me know. Yes, I'm ready for the questions, so please let me know if you have anything to share. Yes, Dr. GP. So if we are having any questions, because I can see in the chat box, they're not having any specific questions, except few complaints about not audible, not slides are not moving. So except that, if you have anything to raise, we can take these questions.
The participants, you may ask your questions.
Yeah, so because the similar presentation we have made during one of the FDP on the HCC only at the CMR Institute. So we have naturally, one observation I have that I may be the maybe not exact person for this kind of area, but we have observed that based on our research studies and based on our research what carried out in the last 4 or 5 years, we have observed that in the information science, this HCC, human-centric computation or human-centered computing is having a lot of role, and we have designed few prototypes to understand this impact or the role of user in the different processes. Right, so we have started exploring the possibility of human presence in the search process. Yes, we have a lot of search engines, search system available in the internet. They are utilizing the user's presence. But now we are designing a very personalized search systems to justify the role of users in these personalized systems. And along with it, in the recent years, we have started working on the different applications area, like in the recommended system. Yeah, we in the recommended systems like like Flipkart and a lot of e-retailing systems, they are having this presence of users already. But we are actually looking for the possible dimensions through which this whole experience of user presence can be enriched in the recommended system. And nowadays we are working upon the question answer based systems. And in all these all system designs, our focus is to understand the role of human presence, right? So that is our philosophy of work. So I hope, things are well delivered and correctly delivered to the participants. Few concepts might be very relevant, few concepts may be little relevant. That is what the balance, exploitation and exploration during the presentation also. And from my side, I can say sorry for these interruptions. Because initially we have got a lot of interruptions, and because during the presentation we have gone through this minimized view of the PPT. So I hope things are okay. It is well delivered from my side. Thank you for the opportunity to the organizer, and best of luck to the participants and to the organization.
Thank you, sir. Thank you for being a part of our FTP. And from the entire family of Guwahati University, I would like to thank you for the opportunity of having you here, sir. And definitely in future also, if we have any opportunity, would we like to get connected to you. So thank you, sir, for being part.
Yes, thank you very much. Thank you.
Thank you, sir. Thank you very much.